we're going to now look at triggers, views, and constraints. Let's start with one of the simplest constraints, and that's a foreign key constraint. I've made a separate table here. This is all from the demo database. I dropped a lot of tables that we're not going to look at, and I took events and I made a second table. We'll look at the DDL for both and we'll see the difference. The DDL for events has no foreign keys, even though venue number refers back to venue number of the venues table. Well, this new table, events con, has a foreign key constraint on venues. In order to do a foreign key constraint, the only thing I needed to add was this line. All of this is the exact create statement that I used to make this table. So it has the same variables, attributes, types, and it even still has the old attribute and type that we're using. At the very bottom, we use a foreign key constraint that makes this table reference venues to make sure that this number exists in venues. Let's see what that looks like when we look at the data. So in the data, we see that each event has an event number and a venue number. If we look in venues, we can see those venue numbers. If we try to delete a venue, I'm going to go ahead and try to delete the made up venue that I did, we'll get an error because our foreign key constraint will fail. So if we do delete from venues where venue no equals 1, foreign key constraint failed. I can't delete from that venue, or I can't delete that venue from the table, because if I did, there would be events that referred to that venue that wouldn't have that constraint met. That's the best example of constraint that you're gonna have to use. You're gonna have to use a foreign key constraint in your final database to make sure that your tables are linked correctly. There's another type of constraint though that I want to show you. And let's see. In order to show you, I'm going to make a new table and just call it people. We already have an employee table and we already have a customer table, but in your final database you might have employees, you might have customers, you might have patients, more likely. And in this create table people, I'm going to have their social security number as a primary key. So everyone has to have a unique social security number. So primary key already has that. But when we're entering it, what would happen if someone entered a social security number of 5 or 2953? Well, if we didn't include this constraint, it would allow that. It has no way of knowing that we're entering a social security number. So if we put in this constraint, the check SSN greater than 100 million and less than 999 million, and then a first name afterwards, we can guarantee that this check will be satisfied every time we enter data into the table. So you could also use this check and or to make sure that it was equal to 3 different values or one of 3 values. And we'll go ahead and create that table, people. And then I'm going to insert something into it. All right, let's do one that's going to fail. and then we'll do one that can succeed. Our check constraint failed. This can help from people entering bad data. So here, instead of 759, it should be 759409657. And that one is a success, and we have the entry into our table. That's an example of a constraint that you'll have to do for your project. You can think of other ways to do constraints. It's all with Boolean values, so having and connect two logical things, or to give someone an option. The next thing we're going to look at is views. Here's an example view. Create view totals as select venue, sum, amount paid as AP from Reservat, which is a table. I guess it's reservations, but they just decided to call it Reservat. Natural join events, natural join venues, group by, venue no, order by, AP, descending. So it's going to take the amount paid per venue and then order them by that amount, descending. Let's look at the data in there. All right, so the Fry track venue has the most money collected of all of our venues. What we're basically doing is a select statement. So from here down is just a normal select statement. Then we're creating view totals as that select statement. So when our values change, let's go into Reservat. All right, I'm going to enter a new reservation number. So I'm going to use 109. I'm going to do it at event number 10. Actually, I take that back. I'll do it at event number 6 with customer number 1, number of tickets 4, and amount paid. I'll do much higher. Let's say they paid a lot more. Alright, so let's see if we can get this on the first try. It sometimes helps to just copy the data that you need to enter for if you're doing a one-off to just test something. So insert into Reservat. I'll do it really high just to make sure we're not conflicting with any other previous. And if we look at events, we want to make the number 1 venue the highest, so we're going to do event number 6. So event number 6, it'll be customer number 1, that doesn't really matter. Number of integer or number of tickets, I'll say they bought 10. Amount paid, 1,000. Payment method, Visa. And actually I'll do cash check, because then I can do null for card number and null for card expiry date, null for pay notes, and purge date null, paid true. Oh, well, I made one mistake. One, I left this here. And my other mistake was that I didn't include values. Well, let's put paid to null. Can we do that? We can. Okay, let's look at the data. So what we just entered went into Reservat. There's our entry. Now if we look at totals, made up venue has automatically been updated to be above FryTrack. So views are nice in that they're basically constantly running queries, and instead of making a new table and kind of doing that, we make a temporary table called a view. A lot of times views are useful when you are combining a lot of data. If you're just doing a simple select statement where you're viewing the data of one table, you don't really need a view for that. Alright, we're going to end with our triggers. There's already a trigger in here that I'm going to demonstrate. And we can see all the triggers of the database by looking at the DDL for everything. So here's our trigger. It's called let go, and after delete on employee, it begins by inserting into the previous employee the values from the old employee number, last name, first name, phone, hire date, salary, and then it makes this new value where it sets the date of when they were let go. So basically an employee's fired and they move into this new table that I created. Sorry, not that one. Previous employee. And I created that by just copying all of the attributes from employee and then including one more attribute called fire date. So let's go into the table, look at the data. Sorry, employee. And we'll figure out who we want to fire. Let's fire O'Brien. Now instead of using just a last name, that would be kind of dangerous. Let's say we have multiple O'Briens that work at the company. Well, we don't want to fire all O'Briens. Instead, we want to use their employee number to fire them. So we're going to do a delete from employee where employee number equals 65. Alright, so we just fired someone. I've already previous run this to test it, so we'll see two names in here. And O'Brien was deleted from the employee table and put into the fired table. And she was fired today. So she's worked here quite a while. I mean, she's put in a good 20, what? Man, I can't do math in my head very easily. She's put in a good 23 years, but I think it was time to let her go. Let's make another trigger. And this trigger is going to allow us to delete from venues. Now remember, when we did a delete from venues where venue no equals 1, we got a foreign key constraint. Well, sometimes we need to delete around foreign key constraints, and there's a few ways to handle that. The way that we're going to handle it is by setting all of the values that violate the constraint in this table to null. So, if I delete venue number 1, that makes this record violate the constraint, because it's referring to a table that, or a record that will no longer exist in the venues table. So in order to get around that, we're going to create a trigger that's called set null. This one's going to happen before the delete on venues. So it's going to change events before a delete on venues happens. It's going to go through for each row. So if there are several events that happen at that venue that we're deleting, then it's going to need to go through all of them. And it's going to update the events table, and to be even more precise, it's going to update the events table that has a constraint, and it's going to set the venue number equal to null where the venue number in this table was previously equal to the old venue number. So before we delete on this, it's going to take out the old venue number. It's going to find all the rows that reference that venue number, and it's going to set them to null. Then it's going to end. All right, let's see if this works. We'll know by trying to delete a venue. And we'll go ahead and delete my made up venue. All right, no error this time. Now if we go to venues, venue number 1 is no longer there. If we go to our events with the constraint, everything that referenced venue number 1 now has a null venue. I believe that these were null beforehand, specifically the ones that have a null entry. But anyway, anyone that had 1 is a null, so now it no longer violates the constraint in order to delete. You'll have to implement this on the project for this week as well. Alright, so that is, we covered triggers, constraints, and views. I hope that this was useful.